Good morning, students. Today we start parallel lines and a transversal. Already we complete 6.1. Now let's see. Here we discuss about the parallel lines and a transversal. Now for this, what we need, suppose we consider two lines. In diagram already you have seen here. So two lines we consider. One line is this M line and another one is N. So these two lines are not parallel. Simply we consider two lines. And if you consider these two lines, then through these two lines, one line passing through here, you see this red line, and which one is we denoted by L. And if a line passing through two non-parallel lines, then this line is known as actually what? Transversal. Is it clear? So that means it is not fixed that only two lines required. It may be more than two. So suppose if two lines here, what we consider here, if a line, that means this line we consider, if a line intersect two or more lines at a distinct points, then the intersecting line is known as what? Transversal. Is it clear? So that's why this red line is known as transversal. So why we discuss about transversal here, now we know. Now here in this figure you see some angles are we write here 1 2 3 4 5 6 7 8. We write some angles as a number we given here. So with respect to this transversal, so this red line is here we mention as a transversal. That means with respect to this M and N, the outside angle, that means here 1 2 and here the outside angles are 7 and 8. So this 1 2 and 7 8, these angles are known as exterior angles. Is it clear? So inside here we get 4 3 5 6. These four are we get inside these two lines. So that's why these 3 4 5 6, these four angles are known as interior angles. Is it clear? Okay. Now next one is corresponding angles. So what is corresponding angles? So in this diagram you see here the corresponding angle means what? So with respect to the transversal, so transversal is this L. With respect to this transversal, now here this angle 1 and angle 5, these two are known as corresponding angles, as well as this angle 2 and angle 6 are known as corresponding angles. Similarly here 4 and 8 known as corresponding angles, and 3 and 7, these two are the corresponding angles. Is it clear? Already written here, you see. Next one is alternate interior angles. So in this diagram you see here alternate interior. So first of all we need the interior part. You see here interior angles are 3 4 5 and 6. So alternate. So for this 4 the alternate is 6, and for 3 the alternate is 5. That's why this 3 and 5 are known as alternate interior angles, as well as this 4 and 6 are known as alternate interior angles. These four angles are inside these two lines, so that's why interior. Is it clear? Then otherwise the other angles are we already mentioned. What? Corresponding angles. So alternate exterior angles. So next one is alternate exterior angles. So exterior angle means the outside of this line. So here the exterior angles are 1 2, and here the exterior angles are 7 and 8. So that's why alternate exterior angle means 1, then the alternate is here 7. So 1 and 7 is known as alternate exterior angles. Similarly 2 and 8 are known as, these 2 and 8 are known as alternate exterior angles. Is it clear? Next one is come here now, interior angles on the same side of the transversal. So here interior angles on the same side of the transversal. So already in your book, if you see the page number 98, there everything is given there. If you want, you see you're in your page number 98. So now here you see alternate interior angles on the same side. That means you see here this one is the transversal, this red line is the transversal on the same side, either on this side or on the left hand side. Either you have to consider on the right hand side or on the left hand side. Interior angle. So interior angle means either 3 4 5 6. If you see here on the same side 3 and 6, if you see the left hand side, then here on the same side interangles, that means you have to write 4 and 5. So 4 and 5 are the interangles on the same side, and 3 and 6 are the interangles on the same side, on the right hand side. So these interangles are also known as consecutive interior angles. Is it clear? Consecutive interior angles, or also it is known as allied interior angles, or also it is known as co-interior angles. So lots of names are here, so that's why we consider here simply we have to say all interior angles on the same side. Is it clear? That means 3 and 6 and 4 and 5. Is it clear? Okay, now here you see axiom 6.3. This axiom 6.3 is very important, and also it is known as corresponding angles axiom. Is it clear? Axiom 6.3 in your book, the statement given. So just you see here this diagram, and with the help of this diagram easily we can understand what is corresponding angles axiom. So in this case what happened, two parallel lines are given to you. Suppose here we consider two parallel line. One parallel line is AB. AB is parallel to CD. Two straight lines are here. And now with respect to these two parallel line, one transversal is there. This red line is we mention as a transversal here. Okay, now according to the axiom 6.3, what is the meaning? If two lines are parallel and one line intersect these two parallel lines, then their corresponding angles are always equal. Is it clear? Then their corresponding angles are always equal. In earlier topic, in the earlier diagram, we just mentioned which two are corresponding angles, but in this case if the lines are parallel, remember, if the lines are parallel and if we draw a transversal, then their corresponding angles are equal. Corresponding angles are equal means this angle 1 is equal with angle 5, corresponding angles. Similarly angle 3 is equal with angle 7, corresponding angles. Similarly these two angles are corresponding and these two angles are corresponding, so corresponding angles are equal. Is it clear? Okay, now here next axiom 6.4. In axiom 6.4 is what? The converse of the earlier one. So if the corresponding angles are equal given to you, that means 1 is equal to 5, 3 is equal to 7, like in this way the other two angles are also if give equal, then what we can say? The lines are parallel. Is it clear? Then we can say the lines are parallel. In axiom 6.3 the lines are parallel, corresponding angles are equal, we prove. And now in axiom 6.4 the corresponding angles are equal, and now what we need to prove? We need to prove these lines are parallel. Is it clear? Okay. Next you see theorem 6.2. So in theorem 6.2 what we have to, again we consider two straight lines and these two straight lines are parallel. So that means AB is parallel to CD, and then we consider a transversal. This line is transversal here. So according to the theorem 6.2 the meaning is what? If two straight lines are parallel and if there is a transversal, then their alternate interior angles are always equal. So in this case if these two are the parallel lines, so obviously 3 and 5 is what? Alternate interior angles. Similarly 4 and 6 is what? Alternate interior angles. So what is the meaning of this theorem 6.2? If two parallel lines are given to you and a transversal is there, then their alternate interior angles are always equal. So that's why 3 is equal with 5 and similarly 4 is equal with 6. Is it clear? Okay, now next one is theorem 6.3. So theorem 6.3 is the converse of 6.2. That means the opposite one. So in this case what we get, like earlier in 6.4 axiom, here in 6.3 what we get? If the alternate interior angles are equal given to you, I repeat this, if alternate interior angles are equal given to you, that means 3 is equal with 5 and 4 is equal with 6 given to you, then what we can say? The lines are parallel. Then we can say the lines are parallel. Is it clear? Okay. Next we move to theorem 6.4 here. So in theorem 6.4 you see this diagram. If two lines are parallel, that means AB parallel to CD, and this one is we consider a transversal, that means the angles on the same side, the interior angles on the same side. That means interior angles on the same side means either you have to take 3, 6 or you have to take 4, 5. The sum of these 3 and 6 is always supplementary. Here written you see supplementary. Supplementary means what? The sum of two angle is 180 degree. That means interior angles on the same side. That means 3 and 6. The sum of these two is 180 degree, or you can say 4 and 5. The sum of 4 and 5 is what? 180 degree. So that's why these two are written here. The meaning of this theorem 6.4 is this one. Is it clear? Okay. Next we move to theorem 6.5. 6.5 is the converse of the 6.4. That means in this case what we get, if the sum of two angle is 180 degree, that means here if 3 plus 6 equal to 180 degree given, that means the meaning is what? The angles are on the same side of the transversal. I repeat this, if the sum is 180 degree, that means the meaning is what? The interior angles are on the same side. Is it clear? In theorem 6.4 what we get, if the interior angles on the same side, then the sum of these two angles are always supplementary. Supplementary means 180 degree, and the 6.5 is the converse of the 6.4. Is it clear? So all the statements are given in your book in page number 100. You can see there. Is it clear? Okay. Okay, now the next topic is lines parallel to the same line. So in this case, what we consider a theorem here. Theorem is mentioned as 6.6. Now in this case what happened? So here 3 lines are there. So the condition is given in such a way that the line L is parallel to M, and at the same time M is parallel to N. So we don't know whether L and N are parallel or not, but the condition is given what? L parallel to M, similarly M is parallel to N. So in this case this red line is a transversal. So in this case if L and M are parallel, that means this here we consider some angles 1, 2, 3. So if this L, M are parallel, that means in this case angle 1 is equal with angle 2. Easily we can say. By which criteria? By corresponding angles. Since two lines are parallel, then their corresponding angles are always equal, we know. So that's why we write 1 equal to 2. Similarly, in the second case, M is parallel to N given to you. So in this case, if these two are parallel, this one is a transversal. So that means angle 2 is equal to angle 3 by corresponding angle condition. So now after that, you see here, we put this one is equation 1 and equation 2. So if you see here, angle 1 is equal to angle 2 as well as angle 2 is equal to angle 3. If you compare these two, 1 is equal to 2, 2 is equal to 3. That means if you compare these two, then what we can say? 1 is equal to 3. So that's why we write 1 equals to 3. So if angle 1 is equal to angle 3, by converse theorem is there. If two corresponding angles are equal, then the lines are what? Obviously the lines are parallel. So that's why if 1 and 3 are the corresponding angles, if these two angles are equal, then obviously the lines are parallel. So that's why L is parallel to N. Is it clear? From here what we can say, if two lines are parallel, L is parallel to M as well as M is parallel to N, without doing anything we can directly say L is also parallel to N. From this proof we can get. Is it clear? Okay. Now we move to exercise 6.2. Now in exercise 6.2 the first question is given. So in this first question the diagram is given like in this way. So in this case what happened, the first condition is given, the angle 50 given here, x given here, y 130 given. So in this case one line is given, this red line here we drawn, and here we need to prove, first of all we have to find out the value of x and y, and after that what we need to prove, we need to prove this AB is parallel to CD. So obviously if AB is parallel to CD we need to prove, so first of all we have to find out this x and y value. If these two x and y values are equal, if we get, suppose if we get x and y values are equal, that means these two are, we can say, alternate interior angles. So according to the theorem, we know if alternate interior angles are equal, then the lines are what? So obviously the lines are parallel. So we get parallel. So from this condition we can prove this result. So that's why first of all we have to write, since you see in this diagram y and 130, these two are what? If two lines are intersect each other, then the opposite angles are, we can say, vertically opposite angles. So from this condition we can say y is equal with 130. That means, that's why we write here y equal to 130. That means these two angles are what? Vertically opposite angles. Again, from the figure you see this red line. If you see in this part, this line is the common ray here, so that means this one is a straight line. So that means obviously the sum of these two angles is how much? 180 degrees. So that's why we write here 50 plus x equal to 180 according to our linear pair exam. So from here if we calculate, then the value of x equal to how much you get? 130. So if you see here equation number 1, y equal to 130 as well as x is also 130. So from 1 to we can, what we get? X is equal with y. If x is equal with y, that means these two are the alternate interior angles. So if alternate interior angles are equal, then the lines are what? Obviously the lines are parallel. So from this condition we can say AB is parallel to CD. Is it clear? Okay. Now you see the second question. According to your second question here given, AB is parallel to CD as well as CD is parallel to EF, and one transversal is also given here. With respect to this, some angles are given x, y and z. So now in this case, if AB is parallel to CD and CD is parallel to EF, so from here easily we can say AB is parallel to EF, because already we proved this one. So that's why here we can say AB is parallel to EF. If AB is parallel to EF, if you see here, now you forgot the CD line, you see here x and z, these two are the interior angles and alternate interior angles. So if AB is parallel to EF, so obviously we can say this x and z are equal according to our alternate interior angle condition. So that's why we write here x equal to z. Is it clear? Okay, now we put this on is equation number 1. After that, again you see here, again AB is parallel to CD given to you. So if AB is parallel to CD, so now this one is the transversal. So x and y are on the same side of the transversal, on the left hand side. So one property we know, if a transversal given to you, if two lines are parallel, then the angles on the same sides, the sum of these two angles are what? Supplementary. Supplementary means what? 180. So that's why we have to write x plus y equals to 180 degree. So we put this one is equation number 2. So now after that, now according to our question, one ratio is given. Ratio is like this: y is to z equals to 3 is to 7. That means we can write y by z equals to 3 by 7. And from here what we can say, y, if you cross multiply this z, then we get 3z by 7. And then we put equation number 3, this one. So now this y value, and in equation number 1 the x value, x equal to z, and in the equation number 3 y equal to this. So this x and y value we have to put in equation number 2. If you put these two value in equation number 2, so x equal, in place of x we have to put z, and in place of y we have to put 3z by 7. So if you put these two value and then if you calculate, then you get the value of z from here. Is it clear? So in this way you have to complete this question. So your task is what? You have to complete the example questions. So the question whatever already solved there, you have to do, you have to try yourself these example questions. In our next class we have to continue the remaining questions from this exercise. Is it clear? Okay, thank you.